Boom. Fix the problem. I'm a genius. All right, divide that number by 2. So I'll do that in a second. C. So you're going to add together your answers from A and B. From A and B. Leaving us to D multiply by the area of a square. So we do that. So what this looks like, as we count these up, I would say I actually have 0 full squares, so that's just me being bad at drawing a picture. Now if I counted up partial squares, I would have said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I get 12 partial squares. It says to divide by 2, so 12 divided by 2 is 6. So what I have is 6 plus 0, which is still 6. I just have 6. Now, up here, if I wanted to, maybe I said this is 5 miles for this lake. What you need to realize is that this 5-mile lake is 5 by 5, so the area of that square is equal to 25 miles squared. So then, in fact, multiply by the area of 1 squared. So for step C, we get 6, but we know that the area of a square is 25 miles. For step D, we need to do our 6 times our 25 to find out that this is 150 square, 150, the other way to write this, and you can do that, 150 miles squared. Alright, that's actually a huge lake, alright? So it all is going to depend on what you have for the area of your square. Alright, so that took up a lot of room and there was a little mishap in there. So I'm going to erase this, but you guys should be ready to rock and roll again after that video took a couple, I don't know what you would call that. It shut down. Alright, area of similar figures. So what I want to do with that is, if 2 polygons are similar, then it is said that their areas are proportional. To the square of the scale factor. So what that looks like is if I have A, B, D, C here, A, B, C, D, and I say this is area is equal to question mark, and I say A to B is 4. Well, then what I would have is 6 over here. I have F, G, H, and that's a closed figure, J. So what I would say is that the scale factor is equal to the 4 to the 6. But you can always reduce to 2 over 3 if you want to keep it simple. So if the scale factor is 2/3, this is where we need the scale factor squared for the areas. And that's why it's underlined here in multiple colors. So I would say 2/3, and I would square both of them. And so the scale factor I'm going to use is 4 over 9. 2 squared is 4, 3 squared is 9. So then over here when I do areas, 4 over 9 has to equal, well, the area for the green one was a question mark, and the area for this one is going to be, let me think of a number that goes into a bunch of stuff. Let's go with area is going to be 81. We'll go inches squared. So then I would use 81 inches squared because this 9 came originally from the 6, which is the bigger figure. So then I go back and I would write question mark inches squared. This is where I get good at cross multiplying. We'd have 4 times 81 is 324 equals 9 question marks. Divide by 9, divide by 9. And you're going to find out that this is 36 inches squared is equal to my question mark area. Alright? So, a couple things to take out of that. A, you can still do cross multiplying on this test. B, you got to know to square it when it comes to scale factors and area. And so then C, you have to get good at this on your own. So doing a couple example problems, A, that takes up time, so you can get all this expertise done and out of the way for the weekend. Maybe you're trying to have fun. So now we got surface areas. And surface areas and things nobody really likes. But we got a formula for each and every one. So how I did this last year is I broke it up. Right? So let's do prisms. Prisms. Right? It could be a square. It could be, right? So it could be a square one. It could be a rectangular, hexagonal, triangular. Right? It could be any of those. And all of them are going to have surface areas that equal the lateral area plus 2 times the base. Right? And then lateral area is going to equal perimeter times height. So remember, P is going to equal perimeter. Capital B is going to be your base area. So you have to use a formula. Formula needed. Especially if it's like a hexagon or something. And then height is still going to be perimeter of base. I'll write that on there. And then height is going to equal the distance between bases. Alright. We also here, if you left enough room, you could do cylinder right here. Alright. Cylinder, not difficult. Alright. Surface area is going to be equal to lateral area plus 2 times the base. Alright. But here's the fun part. Lateral area is equal to 2 pi RH. The base is a circle, so it's pi r squared. So you can also use surface area. So this might be the only surface area equation I write down because you guys get confused. You should probably have 2 pi RH plus 2 pi r squared for the only formula you have for surface area of a cylinder, because that is going to cut corners and have all the variables laid out for you. You just have to know how to multiply it. So then we'd have pyramids, right? In pyramids, we introduce something, and that is called L, which stands for your slant height, right? So you might have a couple different ones you need to know, all right? But pyramids, very similar, except that they only have one base now. So now you're just doing lateral area plus a base area, and your lateral area is now going to use perimeter times slant height divided by 2. So make sure you check that and make sure you have that. Then cones, I'm just kind of making a mess here, but it's color-coded, are the same thing here. Let's see what we can get rid of. All right, lateral area is going to be pi r to the L. Right? So you're going to use slant height there. And then it's still a cone, so it's still the base is pi r squared. So I would suggest writing down surface area is going to be pi r L plus pi r squared. That's that buffering I was talking about. This is probably your best equation for a cone. If it asks for surface area, use this one. If it asks for lateral area, use that one. Okay. Then we got a couple correlations between the rest of them too. Alright, so I'm going to erase this so you guys know how to use these. We'll practice the next couple days. So then we go down to volume of prisms and cylinders. So this is it. We're done sliding down. So volume of prisms and cylinders. So if I have a prism, the volume of that is going to be base times the height. And make sure you know B is area of the base. It doesn't matter what it is. You got to figure it out. Now, the base of a cylinder is always pi r squared. So what I would do for cylinders is you could write volume is equal to pi r squared h. Because cylinders have a base that's a circle. So that's the only one you need there. Pyramids and cones are actually the same thing. Alright? So pyramids, in green here, pyramids, the volume is equal to base times height, but then in math we figure out that you need to divide by 3 to make them equal. For cones, we do it a little bit different. Alright? We know that their base is a circle, so then we can sub out the circle parts for pi r squared h, but then you still divide by 3. So if you know what your base is in cylinders and cones, it's going to be a circle, then you're good to go. Here you might have, for prisms and pyramids, you could have a pentagon, hexagon, square, rectangle. They all could be different. Now, surface area and volume of a sphere, we have been putting those together. So volume of a sphere, volume is going to equal 4 pi r squared, nope, not squared, cubed, right, divided by 3. So volume is going to be cubed. Surface area is going to be the 4, just actually 4 pi r squared. You don't have to divide anything with that one. Now, hemispheres are a little bit smaller. So volume is half a hemisphere is 2 pi r squared divided by 3. Surface area, check this one out. This one's 3 pi r squared. Right, so that's the distance that you can cover up and do some things with. So then the last one will be this ratio of congruent and similar figures. What you want to look at is if I had a cube, getting good at drawing, that's 1 by 1 by 1. And I have a similar solid cube, but I don't know the dimensions of it. I'll say it's x by x by x. What they want you to do is the ratio of lengths. So how do we compare their lengths to each other? Well, if I did that, it'd be 1 to x. Then if I wanted to do their ratio of area, that's going to be 1 to x. But I just told you you have to square it above. So it would be actually 1 over x squared, but it might not simplify to 1 when you do it. Then there's going to be the ratio of volume. So if you see the word ratio, you might want to find this page and look at the bottom of it. And that is going to be cubed. So whatever that simplifies to, you got to cube the values of them. Alright? And so this is actually kind of a shortcut for how to solve all 3 of these. But you got to remember to compare them to each other. You might have to go back up to that area problem where there's an example of how to compare them and how to solve using a proportion. So what we have is some review worksheets. Obviously, you got to come talk to me. We can get those handed out to you. But then you have to be able to ask questions in class on which ones you don't understand. Right? So you got to be circling your worksheets and problems that you're struggling with. Have a good day.